Okay, so the last thing for this week is we're going to look at doing testing, significance testing, and trying to write a confidence interval when we're testing for categorical variables, the difference between two proportions. So you got to have, again, there's some conditions we're going to meet. They have to be independent, and I can't have it related. They can't be the same individual testing for two different things. They got to be two separate samples. There has to be some kind of randomization going on. Your samples have to be less than 10% of the population. If you have too big a sample, it's not going to follow that normal approximation. One book I use say, so this is just like that normal approximation that we looked at. Well, let's see, it's during week 4, I think we did this, right? With the sampling distributions. You take the sample size times the probability of success has to be bigger than 10. I was just looking at the OpenStax book, says 5. Irregardless what you use, it's got to be big enough so that you have that normal curve. Or if you graph the binomial distribution, it looks like a normal curve. So whether it's 10 or 5, usually it's fine. And here's our hypothesis tests. You notice this looks the same as for means, except you're dealing with proportions, and I use P to indicate a proportion. And you can say either they're equal to 0 or equal to each other, same statement. And then you have the two-tailed test, the left-tailed test, the right-tailed test. Okay, same deal. We're going to focus on Rossman chance, the theory-based inference, true proportion scenario. And then once you run that, so what's your claim? Test the conditions, what's the claim? Write your hypotheses. Run the test, report out the z-score. Notice it is a z-score now because we're using that normal approximation for the binomial distribution. It's not a t-score. And report out the p-value, make a decision to reject HO or fail to reject HO, and use your flow chart to make a decision. So here's a problem from the OpenStax book. I unfortunately grabbed the online version, and I couldn't tell you, as in doesn't see any page, have page numbers. So it's question 112 out of the homework. One thing I asked myself is, who's Joan? How do you say her last name? She's one of the co-founders of LinkedIn. Had to Google that. So, are the proportion of college-age males who have an ear pierced? This is as high as the proportion of college females. So, I was looking at that and I'm thinking, do I really want to have a one-tailed test, or do I want to use a two-tailed test? Because they aren't really telling me direction. You could argue that this is going to be are males less than females? So in that case, it would be a left-tailed test. I'm thinking I want to go with a two-tailed test. Just because I haven't run a two-tailed test with you folks, I think it would be just as appropriate to use a left-tailed test here. But then again, this is one of those situations I talked about in my last video, is I might run this and get a p-value that's bigger than 0.5. In that case, I would have gone the wrong way. I would have had to change my claim a little bit and thinking. So I'm thinking it might be safer, less work to just run a two-tailed test. So some things you need for the applet is you need to know the number of successes out of the total number. And I used, instead of 1 and 2, I used M for male and F for female. That's just for me, So that's my X for the male, N for the female, N for the X for the female, and so successes for the females. We should see, well, are 107 males less than 10% of the population? And yes, certainly. Are they independent? I'm assuming they are. Can I do the NP thing here? I don't know. I don't know. I don't know. They didn't tell me enough information to do that, so I guess I won't worry about that. They're independent. I guess we'll just run the test and see. So I got to make sure I have this written down. So when I leave the screen, here, just a minute. I didn't write this down. 20 and 107 and 47 and 92. I'm also not told the level of significance here. I'm just noticing. So we'll probably go with a 5%. So let's go run that test out at Rossman chance. So let's see here. Rossman chances, theory-based, there we go. I'm going to change my scenario to two proportions. I have 107 males, and 20 of them had an earring. And I had 92 females, and 47 of them had nearing. Let me undo this. Let me go, whoops, let's do a confidence interval and see what happens there. I'm noticing that the differences between these two proportions, the difference between 18%, 19%, and 51% is using a 95% confidence level. They're both negative. So how would I answer that as a confidence interval? I would say I'm 95% confident that the true difference in the proportion of males who have an earring and females who have an earring, this is college students, could be as much as 45% of the males, as few as 45%. The true difference would be 40. This is hard. Let's see. Uh, let's see. The percentage of you know what I want to do? I'm going to say this. I think I'm going to reverse this. I'm going to say the percentage of females that have the true difference between the percentage of females that have earrings versus percent of males that have earrings could be as much as 19 or 20% more to as much as 45% more. So it looks like Joan Nyguen, how do you say her last name? I'm being ignorant here. I should have looked that up. She claimed the portion of it at least is as high. So that confidence interval certainly doesn't support her claim, right? And hard question to write a confidence interval for. So let's not. Let's just run the test. Okay, so that is my claim. So let's get some. So I see. So she claimed the proportion of college-age females is at least one ear pierced is as high as the proportion of females. So this is my claim. This is what she's claiming, isn't it? That they're equal, at least as high. So that's different from what we've seen in the past. Now we're saying that HO is the claim. And I'm going to do a two-tailed test. So let's go out. So let's do this now. Let's go out to Rossman Chance. And we'll run a significance test. I'm going to make this be a two-tailed test. You see the way I click on that, I can change the direction. I haven't had to do that up until today, up until right now. I'm going to calculate and look at that test statistic and that p-value. Let's grab that and I'll put that on that other screen, put in the notes. Come on, let's copy that. I'll paste it in here and we'll shrink it up. Okay, so am I gonna, so I stated my claim, I checked the conditions sort of, I wrote HO and HA, I ran the test statistic. Here's my, one thing you need to do for me when for a test, okay, you need to make sure that you, let me highlight this. You need to make sure that you don't just give me the screenshot. I want you to identify the p-value and this the test statistic. You can either write it out, or if you know how to do a highlighting in an image, you can certainly do that too. You want to make sure you identify that. And then what I'm going to do is I'm going to fail to reject it. No, I'm not going to fail to reject that. It's a very small p-value, far less than 5%. So I'm going to reject HO. And how does that help us make a decision? You know how this was the claim that they were the same, or at least the same, she said, and we're going to reject that. So we're going to say they're not the same. So if we go to that flow chart, let's see here. Here's a situation here. Let me get a highlighter going. Here we had a condition of equality. I made that claim BHO. So I've got a condition of equality. Did I reject HO? I sure did. So there's sufficient evidence to warrant the rejection of the claim that let's see, where did I do this on here? She had made the claim that they were the same, and we're going to reject that. So there's not sufficient evidence to support that claim, or we're going to reject that claim. Okay, something like that. Okay, so I'm glad I did this because pick this problem just because I had that. Really, the best thing to do, folks, is jump in and try some of these exercises. You can do paper exercises. You can do the myopen math. I don't know. I could record a lot of videos, but I wanted to make sure that you knew how to use the applet for this. I'll stop this video, and it's been long enough. You've watched enough video.